Okay, so let's check to see if these values are solutions to the system. So a point is a solution if when you plug in the x and the y value, it makes the equation true. So in this top equation, I'm going to plug in -2 for y, and I'm going to plug in 4 for x. So I'm going to get -2 equals 2 times, I'm going to plug in x, which is 4, minus 10. So I'm literally just taking this equation and rewriting it, and I'm looking to see if it's true. So -2 equals 2 times 4 is 8. 8 minus 10 is -2, so it's a true statement for the first equation. And if it's a solution, it needs to work for the other equation as well. So let's check the bottom equation by plugging in 4 for x and -2 for y. So our equation is going to be -2 equals -x, and x is 4, so it's going to be -4 plus 2. And so -4 plus 2 on this side makes -2. That's true. So since the equation is true, when I plug in 4 and -2 for both equations, then it is a solution. For this one, I'm going to plug in 1 for x and 0 for y. So let's take a look at the top equation. So the top equation is 2 times, for x, I'm putting in 1, and then plus y. So y is 0. Let's see if that's equal to 2. 2 times 1 is 2, plus 0 gives me 2 on the left side and the right side. So it works for the top equation. Now we have to check the bottom equation. So let's plug in 1 for x again. So it's going to be 1. And then plus 4 times y. In this case, y is 0. That should be equal to 10. So on the left side, I have 1 plus 4 times 0. 4 times 0 is 0. So I have 1 plus 0. 1 plus 0 is 1. That is not equal to 10. So it didn't work for the second equation, which makes it not a solution. So that's how you test to see if a point is a solution. You plug it in for x and y, and you look to see if it works for both equations. Now let's do some graphing of these systems. So when both equations are in slope-intercept form, you're just going to graph each of them separately. So I have my first equation, which I'm going to graph in blue. So since I know the slope is 1 and the y-intercept is 2, I'm going to plot a point at the y-intercept of 2, and my slope is 1, so I'm going to go up 1 over 1. And with problems like these, we want to make as many points as we can fit on the graph because we're looking for the point where the two lines intersect. So that's going to be my first line. And then let's do our second equation. I'm going to do that in blue. And so my y-intercept there is 1. And my slope is 2. Remember, 2 is really over 1. So that means I'm going to go up 2 over 1. And I actually already found my solution. I already found the point where these two lines cross. They cross at the point 1, 3. So my solution is the point 1, 3. And I picked purple because it's where the blue and the red overlap. So they made purple. All right, for number 2, the equations are not in slope-intercept form. So I'm going to have to take both equations and rewrite them. So that's where we get y alone. So my first step is to move x to the other side. So I subtract 3x to get rid of positive 3x. That gives me 3y equals -3x plus 6. And then I'm going to divide the entire equation by 3 to get y by itself. So I get y is -1x, because I do -3 divided by 3, and 6 divided by 3 is 2. So I'll graph this in red. So I'm going to go to 2 on my y-axis, And then my slope is -1 over 1. So I'm going to go down 1 over 1, down 1 over 1. And I'm going to get as many points as possible. And I'm going to work backwards too by following the pattern just backwards. So that's going to be my line for the first equation. Now we need to do the same thing, but for the second equation. So the second equation is -6x plus 2y equals 4. So I need to get rid of the -6x by doing plus 6x to both sides. And that gives me 2y equals 6x plus 4. And then I need to divide everything in the equation by 2. So I get y equals 3x plus 2. So this one's actually kind of nice because they both have a y-intercept of 2. I'll do this one in blue. And so I already see my solution, but I do need to graph this line. So since my slope is 3 over 1, I'm going to go up 1, 2, 3, and over 1, up 1, 2, 3, and over 1. And I could also go down 3 and back 1 if I wanted a few more points. But really, once you find the point where they overlap, you don't need any additional points other than to graph it. So my solution is that point, which is the point 0, 2. So that's how we solve systems by graphing.